Hello everyone. So in lesson yanamhlanje sizobe sidiscussa question wama number pattern taken from a question paper laka November 2010. So zizocala section yama number pattern la, which is question 2 and question 3. Right, so question 2 and question 3. Question 2 is 17 marks and question 3 is 7 marks. Okay, so ngaphandle ukuthi simoshe isikhathi, let us do question 2. So question 1 bathi evaluate this sigma notation. Right, so question 1 bathi evaluate sigma notation there. So okay, so I was to interpret a sigma notation, it's just the summation, right? So they sort of have like a condensed form of a summation. So if we evaluate this, okay, I think choose it ink right. If we evaluate this sigma notation, so toluguti is the summation from n equals to 1 up to 20 of 3 to the power n minus 2, right? So this is equals to, starting from n is equals to 1, we substitute 1 where we see n. This is equals to 3 to the power minus 1 when you say 1 minus 2 there, and then we are adding because sigma means we add, right? Plus, now we are at 2. When n is equals to 2, and then now no fago 2 la no n khona uzoba no 2 minus 2, so uzoba no 3 to the power 0, right? And then maugu n equals to 3 uzoba no 3 to the power 3 minus 2, which is 3 to the power 1, so it's just 3. And then maugu n is equals to 4 uzoba no 3 to the power 4 minus 2, which is 3 squared, right? And then we do this all the way to n equals to 20, right? When n is equals to 20, sizoba no 3 to the power 20 minus 2, so it's 3 to the power 18, right? So amanye amagama we are summing up these terms, right? So we are summing, mase simplify kuhle, 3 to the power minus 1 is just 1 over 3, and then 3 to the power 0 is just 1, and then siba no 3, and then siba no 3 squared is 9, plus all the way to 3 to the power 18. So 3 to the power 18 over in number kulu, I'll just write 3 to the power 18 there, right? So now we have a series, right? Because we are adding terms here, we have a series. So we have to evaluate what type of a series is this. Is it a geometric series or is it an arithmetic series? So notice from our terms we dwell a series. In order for us to move from 1 over 3 to 1, we multiplied by 3, and then to move from 1 to 3 we multiplied by 3, and then to move from 3 to 9 we also multiplied by 3. Therefore, because we are multiplying each time to move to the next term by 3, it means that we have a geometric series, right? Which means that, so we have a geometric series, right? Where where the common ratio is r equals to 3, and then the first term is 1 over 3, right? So we are just summing a geometric series here. So a formula a geometric series when r is greater than 1, kumbuluti it's Sn equals to a times, equal formula sheet, a times Rn minus 1 divided by r minus 1, right? But then thina siyazi lapha ukuthi n is equals to 20 because we have 20 terms in our series. So therefore calculate S20 kuhle kuhle. So our first term is 1 over 3, and then our common ratio is 3, and then our n is 20 minus 1 divided by 3 minus 1, and then ungavele uyipunche straight ku calculator yakho uzothola ukuthi S20 is equals to inamba enkulu, it's 5811, it's 581130 7 307.3. So now evaluate this sigma notation izokupha this answer. Okay, moving to the next question, which is 2.2. So 2.2, but the following sequence forms a convergent geometric series: 5x, x squared, x cubed over 5, and then but determine the possible values of x lab, right? So I'll tisulela and create space for question 2.2. Okay, so question 2.2, but the following sequence forms a convergent geometric series. So they tell us what we have a geometric series, and that geometric series is convergent, right? And then if a geometric series is convergent, it means the common ratios between minus 1 and 1, right? If a geometric sequence is convergent, therefore this means that R is between 1 and minus 1. R is between minus 1 and 1, right? So you'll get a mark for stating if a geometric sequence is convergent, then the common ratio must be between minus 1 and 1. So what is the common ratio from our sequence there? Remember that the common ratio for a geometric sequence is the second term divided by the first term, or the third term divided by the second term. So R is equals to T2 over T1. What is T2? T2 is x squared, and then T1 is 5x, right? So ngamanye amagama R is equals to x over 5, right? So lapha, because this is a convergent geometric sequence, R is between minus 1 and 1, but then we know the value of R. This means that for the possible values of x for this sequence to be convergent, it means that this condition must hold, right? Which means that the possible values of x must be cross multiplier lapha, or multiplier throughout inequality of 5 uzothola ukuthi the possible values of x for this series sequence to converge, x must be between minus 5 and 5. Okay, so yeah, that is how you do this question. And then nasiya lapha ku 2.2, but if x is equals to 2, calculate the sum to infinity. So if x is equals to 2, then our common ratio is gonna be 2 over 5, right? Because x question 2.2.1 CT, the common ratio is x over 5. So if x is equals to 2, then we will have our common ratio is 2 over 5, and the first term t1, which is a, will be equals to, the first term, so a is equals to the first term, right? And then the first term will be, when you substitute 2 lapha ku first term, so uzoba no 5x, so uzoba no 5 times 2, the first term will be 10, right? So now we know the formula for an infinite geometric series, so it's a over 1 minus r, where r is between -1 and 1. So this means that the sum to infinity, if x is equals to 2, is going to be 10 over 1 minus 2 over 5, which is equals to 50 over 3, 50 over 3, which is equals to 16.67. Yeah, so that is how you do this question. So this condition is important. Convergent, it means that the common ratio is between -1 and 1, right? Otherwise, if the sequence is not convergent, we wouldn't be able to calculate the sum to infinity there. Okay, so now let us do question 2.3. So let us do question 2.3. Then sulela. Question 2.3, but the following arithmetic. So basitshela ukuthi we have an arithmetic sequence. The following arithmetic sequence is given by those numbers. So we have an arithmetic sequence there. Immediately ehloko yakho kumele kudume common difference, right? So we have a common difference there, right? So but how many terms are there in the sequence? So 2.3.1, because we have an arithmetic sequence, we must calculate the common difference. 23, 26, 29, all the way to 101, right? So to move from 20 to 23, you add 3. To move from 23 to 26, you add 3. To move from 26 to 29, you add 3. Therefore, our common difference is 3, right? So because we have a common, because this is an arithmetic sequence, you know we have a common difference, so which means we can apply this formula of Tn, right? So yeah, we can apply formula at Tn. So how many terms are there in the sequence? Kushuthi lapho kumele calculate n, right? So the last term is 101, right? And then we know the first term to be 20. Into enyenza ngo substitute kule formula. We know the first term to be 20, right? And then we know the common difference to be 3. This means that n, now solve for n is equals to 101 minus 20 divided by 3 plus 1, right? So now punch out calculator yakho uzothola ukuthi n is equals to 28. This is 28, right? So question 1, n is equals to 28. So there are 28 terms in the in the sequence. Sorry. So n is equals to 28, right? And then see our question 2.3.2. Okay, so 2.3.2 but the even numbers are removed from the sequence. Calculate the sum of the terms of the remaining sequence. So like 2.3.2, we have our original sequence, right? 20, 23, 26, 29, 32, 35, all the way to 101, right? So if you remove the even terms, right, but the even numbers are removed from the sequence. So if we remove the even numbers, we are removing this is an even number, that is an even number, that is an even number, right? So I must say the last term is not an even number, so we have it there. So calculate the sum of the terms that are remaining. The terms that are remaining now will be 23, 29, 35, all the way to 101. So the remaining terms are odd numbers, so they form a sequence on their own. So in order to move from 23 to 29, we added 6, and then to move from 29 to 35, we added 6. So the new sequence now has a common difference of 6. It's an arithmetic sequence, and the first term there is 23, right? The last term is 101. They want us to calculate the sum of the terms that are remaining in the sequence. So in order to calculate the sum of the terms that are remaining in the sequence, we first need to know how many terms are remaining in that sequence. So we need to calculate the number of terms in this sequence, right? Because now we have an arithmetic sequence, we can just apply this formula like Tn, right? So because we want the number of terms, where we see Tn, we'll just substitute 101, and then the first term is 23, and minus 1, the common difference is 6. So solving for n, we'll find that n is equals to 101 minus 23 divided by 6 plus 1, right? So n will be equals to 14, right? Now punch this to your calculator, told with the n is equals to 14. So 14 terms are remaining in the sequence after removing all the even numbers. So because this is an arithmetic sequence, we can calculate the sum of the terms that are remaining using this formula here. Sn is equals to n over 2, the first term plus the last term, right? So the number of terms that we are summing is 14, right? The first term is 23, the last term is 101. So if you punch this in your calculator, S14 is equals to 868. 868. Right, so yeah, we are now done with question 2, and then we move to question 3. So question 3, it's in a quadratic sequence lapha. They want us to calculate x and then find the formula for Tn, right? So let us copy question 3. Okay, and then create space for question 3. Right, so we have a quadratic sequence lapha. Right, a quadratic sequence, remember, once you hear quadratic sequence, you must think of Tn is equals to an squared plus bn plus c, and then you must think of a second common difference, right? So 3.1, they want us to calculate x from that quadratic sequence. So we have 4, we have 9, we have x, we have 37, and so on. So calculating the first difference, uzobona ukuthi from 4 to 9 we added 5, and then x minus 9, and then we have 37 minus x as our first difference, right? And then the second difference is x minus 9 minus 5, that is x minus 14. And then 37 minus x minus 9, 37 minus x, so 37 minus x minus 9, so to that's 37 minus x plus 9, so this is minus 2x plus 46, right? So that's minus 2x plus 46. Because this is a quadratic sequence, the second difference has to be common, right? Which means that x minus 14 is equals to minus 2x plus 46, right? Now solving for x, taking minus 2 to this side, you'll have 3x. Taking minus 14 to that side, you'll have 60. And then when you divide by x, you'll get, when you divide by 3, you'll get x equals to 20. Right, so that is question 3.1. X is equals to 20, ne? And then ngiyasula lana, and then we go to, okay, x is equals to 20. Let's see question 3.1. X is equals to 20, and then we move on to question 2, to question 3.2 rather. Okay, so question 3.2 bathi calculate the nth term of the sequence. So bafuna formula yaga Tn. Because this is a quadratic sequence, we know that Tn is in the form of an squared plus bn plus c, right? So from our sequence there, we have 4, we have 9, and then we have x, which we calculated to be 20, and then we have 37, and then calculating the first difference, we get 5 here, and then there we get 20 minus 9, which is 11, and then there we get 37 minus 20, which is 17, right? Which is 17, and then the second difference is 6. Because the second difference is 6, we know that 2a is equals to 6, therefore a is equals to 3, right? And then a is equals to 3, right? And then we also have the first difference, the first term of the first difference to be 3a plus b to equals to 5, right? Therefore b is equals to 5 minus 3a, 3a is 3, 5 minus 9, therefore b is equals to minus 4, right? And then we have the first term of the sequence to be a plus b plus c to be equals to 4. We have a already, a is 3, we have b already, b is minus 4, and then we add c, and then we should get 4. This means that c is equals to 4 plus 4 minus 3, c is equals to 9 minus 3. That's 8 minus 3, that is 5, right? Therefore the formula for the end term of the sequence is 3n squared minus 4n plus 5. Yeah, that's it. So if you sort of like don't understand anything kule question, go back to a video let's discuss a quadratic sequence and how, and unubona ukuthi formula yaka tn sithola kanjani. If you still usese confused, feel free ukungithumela i-text lapho ku WhatsApp ungitshele ukuthi yini ungayizwisisi ngizama ukukuchazela. Yeah, that's it for this video. So ivideo elandelayo we'll be solving some more questions from past papers, zama sequences. Yeah, okay, that's it for this video.